Okay, in the previous video I showed you how to calculate the angle of refraction here, and it worked out to be about 30 degrees approximately. However, there are other relationships other than just the angles. Velocity obviously changes, that is the principle why we have refraction, and the angle actually deviates there. So let's actually have a look at how the velocity changes. So we've got Snell's law, sine I over sine R is equal to n2 over n1. However, we've also got velocity 1 divided by velocity 2 and wavelength 1 divided by wavelength 2. So that is an extension of the Snell's law, and the method of derivation I can show at some later stage. However, a lot of books have got it, so you just got to follow it. So we're just going to use that as a tool. So let's have a look at what's happening with the velocity. So n2 over n1 is going to be equal to v1 over v2. Now we're going to assume that because there's a refractive index of 1, even though it's technically not, then the velocity of light travelling through the air is actually equal to the speed of light. So let's substitute our values here. So we have 1.4 divided by 1 is equal to 3 times 10 to the power of 8 meters per second divided by the velocity in the plastic. Now that's an inverse there, so if we do a bit of cross multiplying this time, there's several ways you can do it. Here you've got 1 times 3 times 10 to the power of 8, which is equal to 1.4 times velocity 2. That's times by, so on the other side it will be divided by, that's times by 1, so it is the number. So 3 times 10 to the power of 8 divided by 1.4 will be equal to velocity 2, which equals 2.14 times 10 to the power of 8 meters per second.